I'm your teacher, David Odhiambo. We have point I is stretched to I prime, which is C0, that is the new coordinate, from 1, 0 to C0. Then J prime is stretched from J to J prime, which is 0K along the y-axis. So point I, which is 1, 0, the object and the image can be represented on the Cartesian plane as follows. Now, this is what you have as the object and the image. You plot the respective points A, B, C, and then A prime, B prime, C prime on the Cartesian as shown here. Now, the image A prime, B prime, C prime of the object ABC can also be obtained by reflecting triangle ABC on the line, in the line y is equal to -x. Graph here. So you draw ABC and the image A prime, B prime, and C prime. So from this, you can see that ABC, A prime, B prime, C prime is a reflection of ABC on the line y is equal to x. When you rotate it, remember, positive 90 degrees is we are rotating anti-clockwise direction. So that means where we have I, if we rotate 90 degrees, it's going to be at where J is. That's where I prime is going to be. Then K, when you rotate 90 degrees, is going to be at the point -1, 1. And then J is going to be at the point -1, 0, as shown here on the diagram. So basically what we are doing is we are just rotating the unit square KJ, so that we obtain O prime, I prime, K prime, J prime. Find the matrix representing a reflection on the line y is equal to x. Again, we are going to draw the unit square OIKJ like that. Then we draw the line y is equal to x. Then we are going to reflect on that line. Now to reflect on the line, we did reflection in form 2. So when you reflect point I, it's going to be I prime is going to be at 0, -1 as shown. Then J is going to be, we are going to find J prime at -1, 0 as shown on the diagram. So the point that you are seeing here, point I, is along, if you rotate it through an angle theta as shown on the diagram, the point I prime now has the coordinates now cos theta, sin theta. Then J also, when rotated from where it was initially to where J prime is, it now has the coordinates negative sin theta, cos theta, because it is in the second quadrant. Remember, in the second quadrant, only sign is positive. So we therefore have the rotation of theta about of theta degrees about center 0, 0. I, which was initially 1, 0, after the rotation theta degrees about 0, 0, the image becomes cos theta, sin theta. So let us look at stretch parallel to the x-axis or y-axis invariant. So this we are going to illustrate using the unit square as shown here. We have I, J, K, O, I, K, J. So we are going to stretch it parallel to the x-axis. As we stretch it parallel to the x-axis, the points that are on the y-axis are held constant. That is, y-axis is invariant. The points on the y-axis do not move under the stretch. So we stretch the point I to where I prime. You can see we are moving it to 4. Then K also moves to 4, 1. Now, from the unit